Hi, I'm James Gunny and welcome to History of Infection Part 4, The Curious Case of Dr. Pettenkofer. I want you to come back in time with me to the end of the 19th century. This is a time when science was playing an important role in the day-to-day lives of everyone. Cities have grown massively in the last 100 years thanks to the products of the Industrial Revolution, which was fueled by the application of science. But something lurks in the shadows of these big cities. Unknown killers are abound. Coughing, wheezing and groaning can be heard as people die throughout these entire cities. People in their prime are being killed of unknown infectious diseases. This is part of the story of how we learned what causes an infection. The two main ideas about what caused disease were being hotly debated. These two were infection by some organism like a bacteria, or miasma, or dirty air, which suggested that filth and dirt bred somehow diseases. We now know that contagious diseases are caused by infectious agents such as bacteria, viruses, fungus, proteins, etc., etc. But at some point we didn't know, and the theory of miasma had been such a widely held principle in people's lives for many, many thousands of years that it took some of science's best minds to prove finally and convincingly that it was wrong. But in fairness, what makes more sense to you? That unimaginably small things that you've never seen and can't see without very, very special equipment can somehow get inside your body and cause it to go wrong, or that things that are dirty and smell dirty and make you feel unwell have a process of actually making you physically unwell. Miasma is still found in our use of language. We still say to small children and sometimes adults, don't put that in your mouth, it's dirty or it's unclean, when what we really mean is it may harbour vicious bacteria that will get inside you and potentially kill you. So there are two different hypotheses about what was causing diseases, and what's the best thing to do when you have two different theories that explain these results? Do an experiment. The main two players in the story I wish to share today are Dr. Koch, who most biology students know and giggle at Koch's postulates, and the other, the singular Dr. Pettenkofer, who many people don't know, but I personally think many people should know more about. But this should give you some idea about who is rooting for which idea. But there is a twist. During the end of the 19th century, on the verge of an outbreak of a cholera epidemic, which Koch had predicted using statistics and analysis, and he'd recently identified a new bacterium, Vibrio cholera, he suggested that this outbreak was going to happen, and it did happen. While Pettenkofer was convinced that the outbreak would be due to bad pollution levels in the city, and he believed that bacteria could cause disease, but only in certain environments when an X, Y, and a Z were all present, only then could a bacteria become poisonous. In a sort of way, Pettenkofer was actually right. The pollution allowed for the effective transfer and transmission of bacteria, but Pettenkofer was of a mind to prove his point that cholera wasn't infectious by itself, and he did this with a fantastic self-experiment. So Pettenkofer wrote to Koch and asked him for a sample of his newly identified bacteria. We still do this today in microbiology labs. We still write to each other and ask them for copies of the bacteria that they've published. Once Pettenkofer received it, his experiment was quite simple. He was going to drink it. If Koch was right and cholera is caused by the ingestion of bacterium from an oral to fecal route, then by drinking a large amount of it, surely Pettenkofer would get cholera. So Pettenkofer and a colleague and an independent witness neutralized his stomach acid, removing this as a factor, then administered the vial of cholera to Pettenkofer. Pettenkofer learnt something that day and the following days, that Vibrio cholera to him did not cause the disease cholera. He didn't get it. He was fine. He had a bit of an upset stomach, but certainly nothing on par with cholera. And Pettenkofer naturally thought that this disproved the germ theory of diseases. So how did Pettenkofer survive, or at least keep his trousers intact? A little background on cholera and how it actually works might be useful here. Cholera, the disease, is caused by a bacterium Vibrio cholera. And as few as 10 colony-forming units, these are the live and healthy bacteria that will actually divide once they get into a host, or all that are needed to actually cause a disease state. This is a very small number for an infectious bacteria. To put in perspective, Pettenkofer probably drank close to 1 billion CFU units, colony-forming bacteria. So cholera makes you ill by releasing a toxin that affects how your cells hold onto their water, effectively causing your insides to release all the water into your abdomen, causing it to flush out. This is why you get massively horrific diarrhea, and that's the major symptom of cholera. Massively horrific diarrhea. And the real only treatment we have for cholera, because antibiotics don't really work too well because it's not inside the body, is just fluid replacement therapy. Cholera is still a deadly threat and a big problem in confounding issues such as earthquakes and hurricanes and other natural and man-made disasters. So back to Pettenkofer. How did he survive? Well, allow me to put forward my own pet theory on the subject. Cholera, the bacteria, has an interesting lifestyle. It's highly infectious at low levels, as I said. Only 10 colony-forming units are required. Once the level of cholera builds up inside an effective host, there's a change in the biology of the bacteria. It uses a system called Quorum Sensing, which is actually what I work on for a model in my PhD. Quorum Sensing works by a bacteria releases a small molecule which goes into the environment and acts as a sensor to say to other bacteria, I'm here. When enough bacteria build up in the environment, there's a lot of the signal around, and the bacteria can take a census of the population and know how many of the same bacteria are in the local environment. Most bacteria, like Staph aureus and Pseudomonas, use the system to become more virulent, to turn on their virulence production, like toxins and that sort of thing, once they get to a high enough population density to affect the host. Cholera, however, does it the other way around. They turn off their virulence production once it gets to a high enough population density. But this process wasn't discovered until the end of the 20th century, so there's no way Pettenkofer could have known about it. So Pettenkofer could have survived by this little biological trick. If the Vibrio cholera he drank was at high enough cell density, then its virulence would have just been switched off, leading to just passing straight through him. If he hadn't played fair and failed to neutralise his stomach acid, then there's a good chance he would have got very sick from ingesting this amount of bacteria. He probably would have at least maybe not died, but definitely have got cholera from his own self-experimentation. So what became of Pettenkofer after this? Well, his results were largely ignored, and he moved into obscurity after some actually quite decent work on promoting hygiene to people. You see, Koch had just been consulted on a new water system which he suggested would filter out the bacterium that he suggested caused cholera. In the city of Munich, where the system was built, there were certain streets that got their water from Koch's new inspired design, and some that got their water from a locally infused stream. The ones that got their water from the stream also seemed all to get cholera, while the ones that got it from Koch's new water system, which was specifically designed to filter out the bacteria, didn't get it. So this was quite conclusive proof to people at the time that Koch's ideas were correct and cholera was caused by this bacteria. Koch went on to isolate the bacterium that causes tuberculosis, discovered a way to isolate anthrax from the blood, and rediscovered Vibrio cholera, and eventually won the Nobel Prize in 1905 for his investigations and discoveries into the relations of tuberculosis. Pettenkofer carried on working into his late age, until one night depression overcame him and he took his own life. Although Pettenkofer was wrong about his ideas in general, and they could have only been confounded by his, positive self-experimentation, which was flawed, but he didn't know that and couldn't have known that at the time, I greatly admire his bravery. Even knowing in far greater detail than either of these two men knew about Vibrio cholera, I would never drink a vial of living Vibrio cholera. And Pettenkofer did it without fear because he believed he was correct and he was willing to test his principles. And that, the basis of wanting to test what you've said, is the foundation in which science moves and progresses. And for that alone, we should at least recognise him for willing to put himself in danger to progress science. So thanks for watching. If you have any questions or comments, feel free to leave them below and I'll try to get back to you. Remember to hit subscribe if you want to keep seeing more of these, and like if you've enjoyed it and liked it. Next time I'll be talking about malaria. I hope to see you then. Thanks for watching.